You have now seen what computational linguistics has to handle: structure, meaning, context, discourse, anaphora, dialogue. 9 videos of the specific ways language breaks a computer's assumptions, and every single time we ended the same way, the LLM handles most of it now, implicitly, in the weights, because of math, which is what Lecture 4 is about. This is the recap. Fast, pointed, 9 videos of Lecture 3 in 10 minutes. Then, a preview of what is coming next: probability, vectors, and transformers. The math that lets a computer handle any of what we just walked. Last video, we admitted that most language is not text at all. It is 2 people trading turns with a 200 millisecond gap, which finally closed out the linguistics half of the course. Every layer of language, from syntax up through dialogue, is now on the table, which means we know what the enemy looks like. Now we get to talk about weapons. Here is today's puzzle. Everything we have covered in Lecture 3 has been about what language does, what makes syntax hard, what makes anaphora depend on world knowledge, what makes dialogue different from text. But we have not yet talked about the machinery that lets a computer handle any of it. That machinery is Lecture 4. Today's 3 beats. First, the 10-video recap of Lecture 3, what you should remember. Second, the running theses. Every big idea from L3 in 1 line each. Third, the bridge to Lecture 4, why the next stretch is math and not linguistics. Beat 1, the walk. Video 1, the telescope ambiguity. The man saw the woman with the telescope. Same words, 2 trees, 2 meanings, and structure decided which one you heard. Syntax opened with that. Video 2, constituency versus dependency. Chomsky 1957 versus Tesniere 1959. 2 ways to draw the same sentence. 80 years of linguists arguing. Both live inside every modern LLM now. Video 3, the magic of recursion. Why grammar allows infinite sentences and your brain still gives up somewhere. The dog that the cat that the man saw chased ran away. Grammatically fine. Cognitively impossible. Video 4, semantic roles. Who did what to whom? Agent, patient, instrument. The layer where syntax hands off to meaning. Video 5, word sense disambiguation. Bank. The financial building versus the river edge. Same 3 letters, 2 totally different concepts, and your brain uses context in 100 milliseconds. Video 6, pragmatics. Can you pass the salt? You never ask about capability, you are requesting. The gap between what a sentence says and what it means is pragmatics. Video 7, discourse. John went to the store, he bought milk. Your brain closed the loop. The machine saw 2 strings. Mann and Thompson 1988 said, paragraphs are trees, nucleus and satellite. Long context ate that problem. Video 8, Anaphora. The trophy that did not fit in the suitcase. 1 word flips what it points at. Levesque 2011. The Winograd schema. GPT-4 mostly cracked it through statistics, not physics. Video 9, dialogue. Text is a rehearsed monologue. Dialogue is jointly built, turn-taking with a 200 millisecond gap, common ground, repair, backchannels, voice mode LLMs are the first models that even try, because listening is a harder problem than talking, and that closes the top of the language stack. And now the theses. The one-liners you should walk away with. 1. Structure decides meaning. Same words, different tree, different meaning. 2 grammars, 1 sentence. Constituency and dependency. Both live in every LLM. 3. Grammar is infinite. Recursion. Cognition is not. 4. Semantics is roles, not just words. Who did what to whom. 5. 1 word can mean 2 things. Bank, bass, bat. Context disambiguates. 6. What you say and what you mean are different. Pragmatics. Can you pass the salt is a request, not a question. 7. Paragraphs have shape. Discourse relations, cause, contrast, elaboration. LLMs mostly do this now because of long context. 8. Pronouns need world knowledge. The trophy problem. GPT-4 mostly cracked it. Statistics not physics. 9. Dialogue is not text. Turn-taking, common ground, repair. Voice mode was a bigger deal than it looked. Those are the 9 ideas. Beat 3. The bridge to Lecture 4. Everything we have done so far has been about what language is, structure, meaning, context, discourse, dialogue. But we have not opened the toolbox yet. How does a machine actually do any of this? What is inside a language model? And the honest answer is math, probability, vectors, attention, transformers. That is Lecture 4. 10 videos of the math that makes all of L3 tractable, and it starts small, with counting. 3 takeaways before the quiz. 1. Lecture 3 walked the top of the language stack. Syntax, semantics, pragmatics, discourse, dialogue, everything above the word. 2. Every layer showed the same pattern. Classical NLP struggled. Long context and scale mostly fixed it, but subtle cases still bite modern models. 3. Lecture 4 is the math, probability, vectors, attention, transformers. The toolkit that lets a computer handle any of what we just walked. Quiz 1. What's the one-line summary of Lecture 3? A words are all NLP needs. B above the word. Language is structure, meaning, context, discourse, dialogue. And classical NLP struggled at every layer. C. Syntax is the only real problem. Or D. Everything is solved. B. Layers above the word are where the field's hard problems live. And every layer showed the same shape. Classical NLP tried, mostly failed. Long context and scale mostly fixed it. Subtle cases still break modern models. Lecture 3 is the map of the enemy. Quiz 2. What connects Chomsky 1957 Mann and Thompson 1988 and Levesque 2011? Unrelated papers. B. All 3 are structure as a claim proposals. Sentences, paragraphs, and pronouns are all shaped by hidden structure a machine must recover. C. They all use Python. Or D. They are about phonology. B. Structure claims all the way up the stack. Chomsky drew a tree for sentences. Mann and Thompson drew a tree for paragraphs. Levesque said pronoun resolution requires recovering the world model structure behind the words. Same move, different floor. Quiz 3. What's Lecture 4 about? A more discourse. B. The math toolkit. Probability, vectors, attention, transformers. That makes L3 computable. C. The history of Chomsky. Or D. Dialogue again. B. Math. Probability starts it. N-grams, vectors, attention, transformers. 10 videos of the toolkit that lets a computer actually handle any of what Lecture 3 walked. From language to math. Starting with counting. Back to the puzzle one last time. Lecture 2 showed you the bottom of the language stack, the words. Lecture 3 showed you the top. What happens when words start hooking onto each other? Structure, meaning, context, discourse, dialogue. The layers are still real, and now we know what a machine has to do. Lecture 4 is how. Next lecture, the math toolkit, probability, vectors, attention, transformers. 10 videos of the machinery that lets a computer do anything we just walked. And it starts small, with counting how often the shows up after us is. Hit subscribe, and I will see you in Lecture 4.